Hello, my name is Ethan Palacio, and our project was the use of a computer application to determine contact tracing.
Hello, my name is Thomas Leahy. In this presentation, we will be going over the purpose of the study, the methodology for conducting it, our results, limitations, and our conclusions. Contact tracing, especially in schools and workplaces, can be a slow and monotonous process that is done to prevent people from spreading infections and viruses. The main virus people are worried about during this time is the COVID-19 virus. Due to the pandemic surrounding this virus, the need for contact tracing has been at an all-time high due to people wanting to prevent further infection, to have schools and workplaces remain open, and to simply flatten the curve. The purpose of the study is to create a working contact tracing application, mainly for the purpose of being used in a classroom setting with assigned seating and can be used during post-infection outbreaks. We wanted to provide a simple way for teachers and administrators to contact trace for their schools and classes during these times.
We programmed our application from scratch using the programming language Python. We chose to use this language because I personally had previous experience with it and could use that knowledge to effectively implement our ideas into our program. For our Integrated Development Environment, or IDE for short, we used a program called Visual Studio Code. We also stored our code in a repository in GitHub, which is also where you can find and download a copy of our final product. The images on this slide are some snippets of our program. Since the program is over 900 lines of code, we are unable to show the entire program. However, the snippets we'll be sharing with you today will be from the most important parts of our program. The image on the left here is from our start.py file, which is what is first run when the user opens the program. The user is greeted with a welcome message and two possible options on how to proceed into the program. Line 8 asks the user whether they would like to continue into the program and create a classroom, or if they would like to exit the program. These two options are represented in the numbers 1 and 2 respectively. Line 9 takes the user input that was asked for in line 8 and stores it in the variable action. Further down in the code on line 12, the program performs a check to see which action the user chose. If the user chose option 1, it will direct them into the main function in our classCreation.py file, which we imported at the top of the file. But if they chose option 2, the application will simply close. Continuing with some more code snippets on this slide, we have some of the code from our classCreation.py file that performs a check on each student is infected variable, and for the variables with a yes response stored in them, it will print out the respective students that need to quarantine due to exposure to the initially infected student.
After a lot of coding, research, and testing, we were able to make a successful executable application for our program. The application works as intended, allowing a 1 to 24 student class that can work for a 3x4, 4x3, 4x6, 6x4, and other ratios. Our application is easily accessible, being available on GitHub. Links for our application download can be found in future slides. Overall, the application created passed multiple user tests and has helped us better understand how to apply coding to real-world issues like contact tracing.
During the project, we ran into a limitation in creating the program. This limitation was simply time. Our original idea was to make a website that had our code integrated into it. However, we realized that due to our lack of time, we would have to tone down our original idea. We ended up turning the application into an executable file using a software called PyInstaller. There are also some limitations in our program itself. Our program has a max student count of 24. Another limitation in our program is the seating arrangement. As of right now, our program is limited to either a 4x3 and 3x4 layout for a 12-student classroom, or a 4x6 and 6x4 layout for a 24-student classroom. In conclusion, it is possible to create a working contact tracing program for a post-infection classroom setting, with the maximum and minimum number of students allowed, of course. However, not every goal we had initially was fulfilled. We wanted to make our program be held on a website, but due to complications with time, this never came to be. However, we were able to alter our goals in order to finish with a distributable final project, which comes in the form of an executable file.
We provided a link for our application that you can find on GitHub. You can either copy the link into the search engine or scan the QR code that is provided.
This slide here simply contains the references for our project.